Section 2.8 on page 181 talks about related rates. The homework or these problems start on page, oh man, come on, I can get it right, page 185. So, I'm breaking this into two lectures. Let's get the first one out of the way. It says if A is the area of a circle, we know what the area of a circle is, pi r squared. And r is the radius, and the circle expands as time passes by. Find the a dt in terms of the r dt. Notice here what they're doing. So if I follow the trend that I showed you, if I take a derivative, wouldn't you say dA, pi is a constant, bring the power down, subtract from the power times dr? And do you notice here they're choosing a variable that doesn't match either? So when I say let's go with respect to dt, you'll say, well, the change of the area with respect to time is 2 pi times the radius, the change of the radius with respect to time. So that's a must. That's in part A. In part B, they want to see solve. In part B, they say if the radius of the oil spill increases at a rate of, if the radius increases at a rate of 1 meter every 1 second with respect to time, how fast is the area? How fast is the area of the spill changing when the radius is 30 meters? Now, something that puzzles students, they always think, should we plug this in first? The area is changing depending on how long it's been. Areas are not unique. This area is not exactly the same as this area, and so on and so forth. So, for different radii, it's going to be a different value. So for B, I want that change in area. Well, there it is. The a dt is going to equal 2 pi. The radius they told me is 30 meters. And the r dt they told me is 1 meter per second. So if I multiply those, what do I get? I'll get 60 pi. And the units would be meters times meters per second. And you really don't need to drag the units with you. I don't mind you looking here and saying, well, if it's area, it has to be the square units. If it's volume, the cube units. And if it's length, the linear units. And the time is with respect to. Next problem up, I'd like to look at problem number 8. States the area of a triangle. Well, we know that given two sides and the included angle, the area of a triangle is 1/2 AB, the sine of theta. Here we have three unknowns. We have side A, side B, and theta. So, here they say if A equal 2 centimeters, that A. And if B equal 3 centimeters, and the angle theta is increasing at a rate of 0.2 radians per second. So, d theta dt is 0.2 radians per minute. And if you're not sure what the unit stands for, they're right there. A equal 2 and 3 equal. So those are fixed. How fast? How fast is the area increasing? Well, here, if I take a derivative, now keep in mind, those are fixed. Those are not changing. The angle is changing. So, one of them is 2, one of them is 3, and they're rotating back and forth, but still, the length of those don't change. So, area is actually 1/2 2 times 3 the sine of theta, or area will equal 3 the sine of theta. That's really what the area is. It turns out one of the toughest parts that you need from your previous courses is the equation. This batch of problems I'm dealing with one type, and the next lecture I'll deal with the other type. So now once I get this, if I say what's the change of area with respect to t, well, that is 3 derivative of sine is the cosine of theta d theta dt. And dA dt is really what I'm looking for. That's 3 times the cosine. And I know what this is. They told me what that is. They said it was pi over 3. And the change d theta dt is 0.2 radians per minute. So here I could say dA dt is going to be 3 times 1/2 times 0.2. So that's a 0.1. That is 0.3. Since it's area, right? The units will be, for area, centimeters squared, and time was given in minutes. So I want the units on the very last step. I don't mind you not dragging that with you, but I insist on that. Now in part B they say something slightly different. In part B they say, hey, same area. Area is still 1/2 AB the sine of theta, but now A is fixed to be 2, A doesn't change, but B is increasing at a rate of 1.5 centimeters per minute, and theta is increasing at a rate of 0.2 radians per minute. Now you'll notice what they give us when they say, how fast is the area changing when, now they have to tell me what B is, because for different length of B, the area will change differently, and theta as well. So whatever's changing, they have to give me at what time or at what length. So area equal, if I plug in what I have, I know that A is 2, B the sine of theta. So if I take dA dt, that's the product rule. Derivative of the first times the second plus the first times derivative of sine is the cosine of theta d theta dt. And if I plug in everything that I have, pretty much I'm done. dB dt was actually given to be 1.5. The sine, I know what the angle is, pi over 3, plus b was given to be 3, the cosine of pi over 3, and d theta dt was given to be 0.2. So altogether, the change in the area with respect to t will be 3/2 times sine is radical 3 over 2 plus 3 times 1/2 times 0.2. Given a calculator, you could plug that in at this stage. Not, you leave it like that, it's not a problem. The units are, in this case, centimeters squared per minute. And there it is. If I just want to flip this and make it really nice. There it is. Alright. Next problem. What if A is increasing at a rate of 2.5 centimeters per minute, and B is increasing at a rate of 1.5 centimeters per minute, and theta is increasing at a rate of 0.2 radians per minute. Now, A equal 2, B equal 3, and theta equal pi over 3. A very nice problem. A equal 1/2 AB the sine of theta. When I take a derivative, the A dt, the 1/2 I leave alone. I want to write this slowly and nicely. Oh boy. Show you all these sequence. dA dt is going to equal 1/2 product rule. Derivative of the first, a prime times b plus a times b prime times the second plus the first times derivative of the second, cosine of theta d theta dt. dA dt is going to be 1/2, and fill in the blanks. We know what a prime is. A prime is 2.5 times b. B is 3 plus a, which is a 2, times b prime, which is 1.5. The sine and the angle happen to be pi over 3 plus a times b. A is 2, b is 3. The cosine of pi over 3, d theta dt is 0.2, and that's 1/2 2.5 3 plus 2 times 1.5. The sine is radical 3 over 2 plus 6 times 1/2 times 0.2. That's an acceptable answer on a test. The units will be centimeters squared per minute. Next problem up. If a snowball melts so that its surface area is decreasing, the change in surface area with respect to time, increasing positive, decreasing negative, 1 centimeter squared per minute. Find the rate at which the diameter is changing when the diameter is 10 centimeters. Well, we know that the surface area is 4 pi times r squared. And I know the diameter equal twice the radius, right? So the radius is the diameter divided by 2. So S equal 4 pi. And if I replace r by what it equals, S will be 4 pi d squared over 4. S will equal 4 d squared. And if I take a derivative of that, the change of S with respect to time will be 8 times the diameter. The change of the diameter with respect to time, oh, that's a pi. So when I take a derivative, that's 2 pi. So this is a -1, we know that. 2 pi times 10, the change of the diameter with respect to t. So the change of the diameter with respect to t will be -1 over 20 pi. And the units would be, they told us the diameter is in centimeters and the time was in minutes. And there we go.